Well, this is our startup for week number 5. First problem says find the value of the variable if M is parallel to L. So line M parallel to line L. Here's M, here's L. And we are told that the value or the measure of angle 1, which is right here, equals 2x plus 44. And the measure of angle 5 equals 5x plus 38. Of course, the diagram is not to scale. If these two lines are parallel, we need to identify what type of angles that angle 1 and 2 or angle 1 and 5 are. They are corresponding. And recall that if corresponding angles, or if we have parallel lines, then corresponding angles are congruent. So if we have congruent parts, then we have equal measures. So angle 1 will equal angle 5. So in order to solve, we set them equal to each other. And then from here we solve for x. I'm going to move 2 over 2x across. So 44 is equal to 3x plus 38. I will subtract 38. So we're left with 3x is equal to 6. So x equals 2. We can always plug back in and check if we need to. 2 times 2 is 4, so that gives us 48. And 2 times 5 is 10. 10 plus 38 gives us 48, so that checks out. Number 2. It says find the values of x and y. The diagram is not to scale. Notice that we have these two arrows here and here. Thus that means that these two lines are parallel. If these two lines are parallel, then that means that we have congruent angles here and here. So x minus 3 equals 74. Add 3 to both sides. X is equal to 77. Now there's a couple of ways that we can also solve this one. We can look at it and notice that these 3 angles form a line. We can also use the property, the fact that we have parallel lines and alternate interior angles are congruent. So if that is the case, then I know this angle and this angle are congruent to each other. So that means that we have a 41 degree angle here. 74 plus 41 plus y plus 8 are all 3 angles of a triangle. So 41 plus 74 plus y plus 8 equals 180 because of our triangle angle sum theorem. Notice we get the same situation here just with the simple fact that we would have to replace 74 in for y minus 3. So these 3 angles will equal 180 degrees. So we combine like terms. So when we combine like terms, we get 123 plus y is equal to 180. If we subtract 123, y is equal to, oh yes it is, 57. So there's our 2 values. Y is 57 and x is 77. Number 3. Find the measure of angle Q. The diagram is not to scale. Well, here's angle Q right here. And we have parallel lines cut by transversal. So I have corresponding angles are congruent. So this angle is 50 degrees. I also have vertical angles. So that means that angle R is 70 degrees. And if we notice that we have a line and the angles here of a line are equal to 180. So we have what? Q plus 70 plus 50 equals 180. So Q plus 120 equals 180. Q is equal to 60. Moving on to number 4. It says the measure of angle 1 is 6x. The measure of angle 3 is 120. Find the value of x for P to be parallel to Q. The diagram is not to scale. And we're not told they're parallel. We're asked to determine what x must be in order for the lines of P and Q to be parallel. Well, remember we treat it just like they were parallel. 1 and 3 in this case are corresponding. If lines are parallel, corresponding angles are going to be congruent. So 6x would have to equal 120. That's angle 1 is equal to angle 3. That's the way we're treating it. That's an angle, not an A. So therefore, if we divide, x is equal to 20. Treat it just like they are parallel in order to solve for x. Problem number 5. Find the values of x, y, and z. The diagram is not to scale. First of all, x. I have 3 angles of a triangle are equal to 180. So I can say 56 plus 38 plus x would equal 180. If I combine like terms, I have what? 94 plus x equals 180. So x is equal to 86. Let's plug that in there so we can see. Now, just because we have x, y, and z doesn't mean we have to solve it in that order. Notice that x and z have a property. They form a line. They're a linear pair. Also, if we recall that an exterior angle of a triangle, the exterior angle equals the sum of the 2 remote interior angles. So if I add these two together, that is what z equals. We've already found that to be 94. So z equals 94. The sum of 56 and 38. So if we're looking at this line, we could actually say from the beginning z plus x equals 180. And then if z is equal to 94 degrees, we have another triangle in here. So we would have y plus 94 plus 19 equals 180. So y is equal to 113. Not equal, I'm sorry. Y plus 113 is equal to 180. So if we move across, y is equal to 67. Also, if you're one of those that have to solve in order, another way to look at this, I have this big angle or big triangle. So I would have 56 plus y plus the sum of these two as well, because 38 and 19 is this big angle up here. So there's another way to look at that to solve for y. And lastly, number 6, find the value of x. The diagram is not to scale. We just discussed the remote interior angles theorem, which means if I have an exterior angle of a triangle, it equals the sum of the 2 remote interior angles. Exterior angle equals the sum of the 2 remote interior angles. So 105 will equal 72 plus x. So in order to solve for x, we subtract 72 from both sides. X is equal to 33. Of course, if you did not see that, we can always find that 105 and let's call it y would equal 180 because they form a line. So y equals 75. Then you can say 75 plus 72 plus x equals 180. Still get the same solution, just a different way to solve for it. And that is your startup for week number 5.